we don't even know what they are used for. Some of them are used for, they are used for food, medicine. Some of them can be used for production of herbicide. Some of them can be used for production of insecticide. Then soil amendment. So here, I have 3 plants that are of interest to me, which I want to use as soil amendment to produce my first crop, which is Tempera occidentalis. Then one of them is Siam wheat. Yoruba used to call it Akitola. They call it Cromolina odorata. Now looking at this, it's in the olden days when I was in the village, where they call the odorata, my grandfather, my grandfather will go around wherever I see these plants, will cultivate it. You have to, cut the weed, put fire, and at the end of the day, if they put any crop on it, it will do as if there's fertilizer. No fertilizer there. So it is known to be very, very, good as a kind of soil fertility. It improves soil fertility. So you can see here usefulness of this. It's used for organic fertilizer, medicinal purpose. It has anti-cancer, anti-diabetic, anti-hepatotoxic, anti-inflammatory, antimicrobial. It's full of antioxidant property and what have you. The second weed or second plant is known as Mexican flower. It has an unusual high nutrient concentration. You can see 3.5% nitrogen, phosphorus, potassium, very high. So the uses, the people use it for building material, fuel, compost, land demarcation, ornamental, and what have you, other things. Now the third one now is this. They call it Agumaliye. That is Gliricidia sepium. It's everywhere. So look at it. You can see the nutrient composition. Look at living. It's used for living space. In Nigeria, the state where I came from, Odo State, we plant cocoa a lot. So there we normally use plantain to nurse our cocoa. But this is another thing that is being used to nurse cocoa all over, maybe like Mexico and whatever, all over the world. They use this to tame cocoa until they said, when you use plantain to nurse cocoa, when the plantain is grown up, so the use is now living fence, fuel fodder, green manure, shade, support for crops, erosion control, and what have you. That's Gliricidia sepium. Then I tend to let me see what I can do to make sure that I use this in producing Tempera occidentalis. So, you see, nowadays everybody is craving for organic food. Then I look at it. Somebody went to poultry. You pick some manure from poultry, and you take it to your farm. You cure it. Everything is okay. Now you start applying this to your crop and say, this is organic food I produce. To me, as far as I'm concerned, it is not pure organic. It is partial organic. You ask me why? You see, some of those feed, talk about organic, we are talking about using natural feed to produce food. So that one it has been polluted, either in their water or whatever. So looking at how we can use maybe ordinary leaf to produce all these crops. So that was what brought about this. Then is to study the response of the Tempera occidentalis to sowing method. Then 2, to examine the growth, fresh leaf, and fruit yield response of Tempera occidentalis to green biomass of Cromolina odorata, Titonia, Divosporia, and Gliricidia sepium, and NPK. Material and methods. In 2019, I carried out this experiment. So, the planting cell analysis follows standard procedure. The mineral composition of grain biomass used. We also took the composition that is used standard procedure as well. So this is the treatment, that's experimental treatment. In 9 hots, we normally, the way we plant our ugu here, Tempera, is by putting them, set them in the tray. Then you water the tree, you put them in the nursery. But here I just thought of it. If you want to plant like maybe 10 hectares, how do you go about that? It would have been easy for you to be carrying trees up and down. So I now thought of it. Why don't you plant directly on the field? Then after planting directly on the field, then let's see the one you plant, whether you have an advantage, whether there will be any advantage, the one in the nursery and the one on the field. And that was what I did. So here what I did was I had the Lucidia Civium, 10 tons per hectare, then Chromolina odorata, 10 tons, then Teutonia diphtheria, I have 10 tons as well. Then I now use the combination of the three as a treatment as well. Then thereafter I use our almighty NPK, which everybody now is saying is causing cancer, it's not friendly, it's not environmental friendly, what have you. Then I have control, which has no treatment at all. Then the experimental design. It was 2x6 factorial arrangement fitted into split plot design. Then I have 3 replicates. Then the plot size was 2 meters by 3. That is, the area of each plot was 6 meters square. Then agronomic practices like land preparation, plow, harrowing, everything was done. Then sowing, that's seed sowing. The direct was sown on the field at the spacing of 50 cm by 75 cm. Then I have a total of 25 plants per plot there. Then amendments, preparation and application, the green biomass, and what I've said so far, I cut them into pieces, apply them at 4 weeks after sowing. Then at 2 weeks after sowing that one in the nursery, I took them to the field to join the original one that was directly planted. So the one I planted directly on the field, I call it direct sowing. The one in the nursery, I call it indirect sowing. That was what I did. Then FPK was also applied at the same time with the other treatments at the same time. Then data collection. 10 plants were tagged in each plot. Then the data collected were vine length, number of leaves per plant, number of vine, stem girth, leaf weight per plot, leaf weight per hectare, and fruit leaves per hectare. Okay. Then data analysis. The collected data was subjected to analysis of variance and over using GenStats 2014 statistical package. The mix was separated using Duncan multiple range test, DMRT, at 5% probability level. Then result. Okay, this was what I said, chemical and physical characteristic of experimental soil. That was replanting soil analysis. That is the chemical composition of the amendment used for the treatment, as you can see. Then, now I have effect of planting or sowing. I use them interchangeably. Sowing methods and soil amendment on the number of leaves, number of vine length, stem depth of Hesperia stem values. Then if you can check the for there, you will see that direct sowing produced the number of leaves that was significantly higher than that of indirect sowing. So anywhere you see the letters there, that is Duncan. They tell you that if the letters are the same, that means they are not significantly different from each other. But if they are not, then okay. So looking at it here, the control had the least number of leaves, which was significantly lower than the others. Then here, our almighty NPK gave us the highest number of leaves as well. But here is interesting to know that the combination of this green biomass gave us a value which was significantly lower than that obtained from NPK, was higher than the other treatments. Then, if you go to the number of vine, the same thing repeated itself. Direct sowing gave the number of vine that was higher than that of indirect, which was significantly higher, so to speak. Then look at the amendment. We see there that the control, which has no treatment at all, gave the list of the number of vine, where the combination of the treatment, that's the green biomass, gave us a value which was significantly lower than that obtained from NPK, but higher than the other treatment in this experiment. Then go to vine length. That vine length follows the same trend. As we can see here, it produced that is direct sowing, gave the vine length that was significantly higher than that of the indirect. Then likewise, we see that the control, which has nothing, gave the least vine length, and the shortest vine length, while NPK gave the highest vine length that was significantly higher than the other treatment. Then stem guard as well. On the field, it shows there that stem guard was significantly influenced by direct sowing. That direct sowing gave the highest stem guard, that is, the thing grew has thicker stem than that of indirect. And that one can be explained because when you plant something, from the nursery, you take it to the field, you disturb the growth process because the roots you have to uproot. But this one has been on the field for a while, and that will help a lot. So looking at it also, the control here, when you talk about soil amendment, the control here was that control gave the least stem depth, which was lower than the others, while the MPK gave the highest stem depth. And also here you can see that the combination of the biomass, green biomass, that's Brucidia, Teutonia, the Acromolina, give us a value which which is significantly lower than that of NPK but higher than the others. Now, effect of planting methods and soil amendment on the fresh leaf with a plot, fresh leaf weight per hectare, and fruit yield of accidentally. Now, looking at it here, indirect sowing here gave a value that is significantly lower than that of direct sowing. Okay, now we look at the NPK. NPK gave us the highest leaf weight per plot, which was significantly higher than the other treatments. But the control here, we can see that it gave the least. But looking at the leaf weight, looking at the leaf weight that was obtained as per plot from the treatment of Brucidia and Teutonia, you can see that there was no significant difference between the value obtained from